Okay, so welcome everybody. Thanks you for coming. First, before I start, I just want to say that this is hands down the coolest place I had to give a talk in. So good job, ContainerDays people. And I think I got to take a picture of this because you look very good. I'll just take a. Opa. Great. So now we got this out of the way. So thank you again for coming. Today we're going to talk about how to use Helm to speed up your engineering and shift left. Maybe just with the raise of hands, how many of you have heard of Helm or have any experience with Helm? Wonderful. Okay, that's perfect. Great. So let me just introduce myself. My name is Guy. I'm a solution architect working for CodeFresh. CodeFresh is the first CI/CD platform designed specifically for Kubernetes. We'll see today in the demo, and we are also one of the main contributors to the Helm project. You can see my email address there, and the bottom it will be on the rest of the slides as well. So if you have any questions, feel free to send me an email. So let's start with going over the agenda real quick. We'll review some different reasons why teams choose Kubernetes. Then we'll focus mainly on velocity and the importance of high velocity and what is shift left. Then we'll do just a very quick introduction to Helm. I was counting on that most of you will have some familiarity with Helm, and I see that you do, which is great. Then we'll jump into a live demo, and in this demo you see that I posted a Git repository there that you can then play around with the app that I'm going to use in the demo, as well as we have a blog post with a how-to guide on exactly how to implement the same workflow that I'm showing in the demo. So basically, we're going to show you a live CI/CD workflow that creates an offhand environment using Helm, then runs some tests on it, and then continues to deploy to staging and production. So first, why do teams choose Kubernetes? And you can see a bunch of different reasons here on the screen, like scalability, avoiding downtime, reducing cost, developer velocity, and infrastructure abstraction. But today we're going to focus mainly on velocity and why high velocity is so important. So I broke it down here to about 3 reasons. And let's start with reduced risk. So if you think about it, if you deploy your changes once a quarter or even once every 2 weeks, you usually mean that you bundle up a lot of changes together and then you push them all at once to production. And this can cause and there's a high chance that there'll be some bugs, maybe some weird interactions between your features, and it's difficult then to identify exactly what's broken, fix it, and push back. So if you have your CD pipelines implemented and you're deploying, like we'll see in the demo, these environments for testing earlier in the development lifecycle, you can deploy multiple times a day, sometimes even multiple times an hour, and then potentially and ideally for every commit, you'll push it to production. Then it's much easier to identify issues, roll back, and fix them. Same thing goes for cost efficiency. So if you think about it, all these changes that you make as an engineering organization, by the end of the day, you're doing it to provide value to your users. And every time that you create a new feature, but you just store it instead of immediately deploying it, it's basically wasted money because you could have immediately deploy it, get feedback much faster from your users, and then fix and respond quickly. And last thing, which is also actually an interesting one, is security. And a lot of people think that security and high velocity don't necessarily go together. I think it's actually the opposite, because if you think about it, when there's a data breach, it doesn't necessarily mean that the code was shipped with known vulnerabilities and a data breach. Many times, what happens is, you work on some feature, and at the time, it's considered secure, but then it sits there for a few months or a year, and once you actually deploy to production, and during that year, maybe some vulnerabilities were discovered, and then it's unsecure. So if you do move to this mode of high velocity, deploying for your services multiple times a day for each service, every engineer is responsible for his own code and features, then it's easier to find these things faster, and it makes the whole development faster and also cheaper. So I mentioned shift left, and I'll explain exactly what we mean when we say shift left here in CodeFresh, but here you can see just a quote from one of our users from Steelcase, saying that when their engineers commit code, CodeFresh runs all the testing that they need and spins up an environment just for that feature that they worked on. This is what we're going to see in the demo as well. Then their QA and design teams can access this unique environment and do a level of testing that was just not possible before. And the whole test cycle goes from 3 days to 3 hours. So what is shift left? So if you look at this diagram, this is a classic, typical dev Git release flow, where every time you make a change, can you hear me? Yep, okay. Every time you make a change, you go maybe through a unit test, then issue a pull request, and go through a code review. And only then, after the code review and the pull request, you eventually get an environment, like a staging environment, where you can run stuff like integration tests, performance tests, security testing, etc. And the reason that you couldn't do that earlier in the lifecycle is because you simply didn't have an environment to do so. So this point here, this staging point, becomes a bottleneck where, as an organization, especially when you start growing and having more engineers and more teams, you need to being able to manage a lot of environments, or just like a huge environment that everybody works on. Then you're not working on something which is clean. And it's a huge headache, and it's also very costly in terms of the code review. Because if you think about it, let's say you're an engineer, you're working on a new code, and you're making a change. You go through a unit test, and then you go through a code review. Then there's somebody spending maybe 30 minutes of their time browsing through your code, looking at it, maybe then passing it, and then you can go to deploy to the staging environment. You start running those integration tests, and you find that maybe your code wasn't even ready for the real world. Maybe there is performance issues. Maybe there is security vulnerabilities. And this guy that ran the code review just wasted a bunch of time. So what we try to promote, and I'll show you how we do that at CodeFresh, is to, for every change that you're making, immediately run those integration tests, those performance tests, all those kinds of things earlier in the development lifecycle by having this environment using Helm. And then by the time you reach the code review and the pull request, the person that does the code review for you, he knows that these changes that you made already passed all those things like integration tests and performance tests, and he's not wasting his time. So what is Helm? I was very happy to see all your hands here, and see that most of you are familiar with Helm. For those who don't know it, Helm is a package manager for Kubernetes. So if you think about YAM or apt or NPM for node packages, it's a similar thing for Kubernetes. It lets you group multiple Kubernetes manifests and then treat them as a single entity, which is called a chart. It also has a built-in templating engine for Kubernetes manifests. You can create a chart of charts, which some of you are probably familiar as an umbrella chart, where you can bundle up all your dependencies and then install them all at once. And it has the ability to create catalog of applications, like which is called Helm repositories, which is similarly to like an NPM registry for that matter. So we're ready for the demo. Just before we start, I'll talk a little bit about CodeFresh. So CodeFresh is a container-native CI/CD platform designed specifically for microservices and Kubernetes. It's container-native in the sense that every step in the pipeline, and you can see this diagram on the right-hand side, every step there runs in the context of a Docker image, which means it has its own isolated container, and then you don't have to maintain slaves as virtual machines like in the old days, where you have to pre-install all the tools that all of your teams needs on this build node. Here you just provide the Docker image for each step and run it and then continue. The platform is pretty intuitive and robust. The UI is very friendly, as we'll see in a minute. It's enterprise ready. It has features like SSO and role permissions, RBAC, stuff like that. You can create thousands of pipelines, and a flexible delivery model where you can deploy both to on-prem, hybrid, or SaaS. So a little pray for the demo gods before we start. And let's start. So what you see here on the screen, this is CodeFresh. This is the platform. You can sign up for free, get a free account, and then start creating your pipelines. So what you'll see once you sign up is this project view. And in each project, you can create multiple pipelines. And we can click on one of these projects just to show you the concept of Docker-based pipelines as we know it. So this is how it looks like. This is the pipeline view. You see that the pipeline itself is created using a declarative YAML. And you can choose if you want to import this YAML file from your Git repository or to create it inline inside the platform. And just to quickly understand this concept of Docker-based pipelines, you see that, let's say I have a microservice that I created using Node. I don't need to pre-install Node with the version that I need on a slave, on a build node. I can just provide a Docker image that has Node with the version that I need installed on, and then run any commands in the context of this Docker image to package my microservice. Then let's say in the next step, I have another microservice that uses a different version of Node. Then there's no problem. I can just bring a different Docker image that has the relevant version of Node, and then again package this application, this microservice, and this is true for any kind of tool. So like Python or AWS CLI or Terraform or every tool that has a CLI or an API that can be easily packaged in a Docker image can be then used in a step this way. Now let's see how we can deploy using Helm to our Kubernetes clusters. And for that, we actually created a dedicated, what we call plugin in CodeFresh, but it's actually just a Docker image. So all of the steps that I showed you earlier are what we call freestyle steps, where you bring any image, then run any commands in the context of that image. But we also have some predefined steps, like let's say you want to clone your repository. You can just set the type of the step as git clone, and then we will get the JSON payload from your Git repository, from the webhook, and we can use the repo owner and the repo name for that repo. Then, for example, for building a Docker image, you don't need to run any Docker commands. You just set the type of the step as build. You provide a Docker file for this microservice, and we will build a Docker image for you and push it to the private Docker registry that you get with CodeFresh. So every account gets a private Docker registry and a Helm repository. And then let's see how we handle Helm. So let's say you have a chart in your Git repository and you want to push it to a Helm repository. Then we created this Docker image called CF Step Helm, which is a Docker image, but it's created as a self-contained function in the sense that you don't have to run any script or any code. You just provide a set of environment variables with the action that you want to do in this step. So here I want to push my Helm chart to a Helm repository. I just set the action variable as push, the chart reference as the name of my chart, and the repo URL as the URL of my repository. Then to deploy my Helm chart to my Kubernetes cluster, I provide a different set of environment variables, like, again, the name of my chart, but then the release name and the queue of context as the Kubernetes cluster that I want to deploy to. And you can see this step and also a bunch of other steps in this free library that we created for CodeFresh. So these are different plugins that we created. Again, they're all free, they're open source, and they're all Docker images. So let's say you want to perform a blue-green deployment or canary deployment to your Kubernetes cluster. You can just use these images, and again, they are created as self-contained functions that just pass the variables that you need. Now let's go ahead and run our demo. So the application that I'm going to use for the demo is called the Example Voting App. Some of you might be familiar with it, as it's a popular demo application that uses Docker Compose, but we took it and then migrated it into Helm charts. And just to start, let me run this demo bot that I created here. And this will do perform some things like git commit, check out a branch, then issue a pull request. And those things will then trigger my main pipeline, which I'll show you in a second. So this is my pipeline. Let's see. Okay. So I can see it here, and again, I'm pulling my YAML file from my Git repository. And what I did here is I created triggers, and you create a lot of different triggers like cron that you're probably familiar with. But what I'm going to focus on is Git-based triggers. So you can choose which Git repository you want to trigger your pipelines based on. And it doesn't have to be the same repository that you're going to clone as part of the pipeline. And then you can choose many different trigger events like a commit or a tag, but also many different pull request events, like every time a pull request is opened or reopened or edited, etc. And you can use these filters here to specify, only if a pull request is opened on a specific branch, or a specific naming convention for your branches. For a pull request comment, you can filter according to the target branch of your pull request. And also this last field here is for monorepo support. So if you have multiple projects inside the same repository, and you want to separate these projects and run this pipeline only for a specific project, you can simply set a path in this field, and then only if changes were made to files or folders within this path, it will trigger the pipeline. And you can also add specific environment variables for each trigger. So now let's go to our repository, and I see that a new pull request was created. I can click on it, and I see that CodeFresh now communicates back to my Git repository, and I can see this pipeline actually running live. So it starts with cloning my repository. It will then build the different Docker images for my application. So I have a Redis microservice and a Postgres, and then a backend server called Worker that will communicate and handle everything between Redis and Postgres, and two front-end servers, one for voting and one for showing me the results. So it will build all of these images in parallel, then run security scans on these images, and then we'll create my Helm environment for my pull request. So one more thing to mention is that every pipeline in CodeFresh gets persistent volume, and then once you clone your repository, all of your project files will be then placed on this volume and will be accessible to all the next steps. Same thing for dependencies. So let's say you download some Node modules or Go modules as part of the first steps for the preparation for the pipeline. These dependencies will be available automatically for the next steps, but also for the next executions of this pipeline, because this volume is persistent. So the next time you run this pipeline, you won't even have to download the Node modules or Go modules again, because they will be there on the volume. Now I can click on each of these steps and see the logs. I can see that, for example, here for building the Docker images, it also took my images from the cache, and we also provide caching on the intermediate layers of the Docker image. So let's say you make some changes to the end of your Docker file, and you run this pipeline again that needs to build your Docker image. It will take all the existing layers from the cache and build only the new ones. So now it's running a security scan on my images. I can go back here, and I see that two other pipelines that ran as part of this trigger already passed, the tests and the vote. And in a few seconds, I'm going to have my my Helm environment created, and then we'll jump into the environment itself, and we'll see we have a lot of Helm-related features here, like the ability to see all of your releases. We'll see how to have one-click rollbacks to previous versions. That's another thing that Helm provides, and also like a visual board that can show me exactly what's running on each of my environments. After, by the way, I'm going to create this this Helm environment, I'm going to run some DVT tests, so deployment verification tests, using Selenium on this pull request environment, and only if these tests pass successfully, then I'll push my package into staging and then production. So this is, by the way, how the step of creating my pull request environment will look like. You see, I'm using this Helm image, and then simply provide this set of environment variables like I showed you earlier. So I'm choosing the chart that I want to deploy. The release name will get the name of my branch together with the pull request number and the repo name. So I'll see it later on in the actual release. It will be identical to the name that I have for my feature branch. And here we reached this step for creating the pull request environment. Okay. Let's see here. By the way, you can click on the metrics here to see the usage of your pipeline. You can see the memory consumption, the CPU consumption for every step separately. Let's see. Okay. Let's reload this page, see if it started already. It's stuck on the main part. Okay. Now I see that it started. It's now going to pull this image and then run Helm install to install my new release. And this should take just a few seconds. And now I see that it's done. Okay, so my new environment is ready. And now I'm going to run these DVT tests on this environment. And only if they pass successfully, I'm then going to push my changes into staging and then to production as well. So if I go back here to my Git repository, I see that I can then access my pull request environment directly here from my GitHub repository, and this is how it will look like in CodeFresh. So you see that this is the name of my release. It's called San Francisco or Disney, and if I go back to my Git repository, I see that this is exactly the name of my branch. So again, I'm creating a dedicated offhand environment for my feature branch, and here I'm going to see all of the services that are running for this environment. Sorry, so let's open it again. And once the endpoints are available, I can even click on them and see my environment running live. Yep, so I see that this microservice is ready. And I can click on it and see my application. So this is a cat versus dog voting app. I'm on the dog side, by the way. I don't know about you. And now it's going to run again my tests. So I see it's running my test. By the way, once these tests are completed, we have a dedicated step that will take the test artifacts, store them in your cloud storage like S3 or Google Cloud Storage, and then we'll be able to show you results directly here in the platform. And another cool thing that you can see here is that if I go to my Helm releases dashboard, I see all of my Kubernetes clusters here, and I can go to my production environment, my production release, which I change frequently. I upgrade it, and here again I can see all of my services. But as Helm also helps me with version management on my releases, I can go and click on the history here and then see all the previous revisions of this release, and I can see the changes between these releases. I can roll back to previous release just by one click. So I'll show you this in a second once it loads. Let's see what's the status here. Okay, still running. Okay. So again, this is my production environment. I see the services. Let's click on the history to see what's going on here. The internet is a bit slow. I don't know why it's stuck right now. Let's open it here. Okay. So one more thing I want to show you is that you can also create these Kanban boards that gives you like a nice visual representation of what's running on each of your environments. And this is also pretty cool. So I'm seeing my pull request environment, which is now actually being taken down because once the tests are finished, we will automatically remove it. But I can compare between what's deployed to my pull request environment and staging environment and production environment, and I can see exactly the chart version that is running in each environment. I can see the app version, and what I can do is, if I want to then promote a release from one environment to another, so I can just drag and drop like this, and it will then pop up this window, ask me what's the target environment that I would like to promote my release to. I can add any variables to support this promotion, and nicely here from the UI, promote a release from one environment to another. One more thing that you can see here is because we store all the images automatically on this private Docker registry that you get with CodeFresh, I can click on the actual image and then see all of the information that I need about this image. So I can see when this image was created, if it was then pushed to another registry. I can see different annotations that were pushed as part of the pipeline to my Docker image. So I can link like a Jira ticket here, or like a Claire report for security scans, a quality flag, stuff like that. I can see all of the layers of my Docker image. Under the logs, I can see the pipeline that ran, that created my Docker image. I can see the Docker file, but I think most importantly, and this is one of the features that I like the best, is that you have full code to cloud traceability. Because you have both CI and CD capabilities in the same platform, then you can trace back from this image that is currently running in production all the way back to the commit SHA that the developer made that then built this production image. So, you know, an interesting question all the time is, you know, in this release, does it include my latest commit? So here you can see this traceability immediately. And let's see if our pipeline is now ready. Oh, by the way, this is how the history looks like. So this is for my production environment. I can see all of the latest releases, and I can see the changes in the chart YAML for here. For example, this is just a change in the version. But I can also click here to do a rollback to a previous version, any version that I want. So easy rollbacks, promotion between environments, automatically creation of environments for testing. And then finally, once my pipeline is completed, I can go and see the results. So you see here, test report. It will show me the results of my security scans that I did. If I go back to the DVT pipeline that ran my DVT test, we bundle it inside an Allura framework. So if you run Selenium tests, Mocha, RSpec, stuff like that, you can see the results of your tests that you did on your off-end environment directly here inside the platform. So going back and just jump into the summary here. So we discussed high velocity, and we saw how it provides better cost efficiency and reduced risk. So deploy faster, deploy more frequently. We talked about shifting left. So, you know, shifting those integrations, performance tests, all those kinds of things earlier in the development life cycle to not have this staging point bottleneck. We saw how to use Helm to create a one-off environment for staging, to run those tests. And we did all those things in the CodeFresh platform, so both CI and CD, and the ability to manage your environments. Thank you very much. Yeah. Questions? Anybody? Yep. Sorry, what's the question again? If you have a... Yep. So this platform, yeah, in a sense, it's a replacement for Jenkins because Jenkins, in a way, is a task manager to run your CI pipelines, but it doesn't have any CD deployment capabilities out of the box. So you have to use either third-party tools or write custom scripts. Here, we also, by the way, have like a Jenkins step that you can use if you want to run your CI part in Jenkins, but we can replace Jenkins completely in that. Any other questions? So again, if you have questions, you can send them here, and you can sign up for a free account there.